Hi, we are going to talk about how to multiply matrices. But before we're going to talk about how to actually multiply them, we need to understand that sometimes matrix multiplication is not possible. So you need to know the conditions that we need to meet for that. So the requirement is when you multiply two matrices, to be able to do that, the number of columns in the first matrix must equal to the number of rows in the second matrix. So first of all, what does it look like? For example, if I want to take a matrix that's a 2 by 3 and I want to multiply it by the matrix that is going to be 3 by 4, this is the number of columns in the second matrix, this is the number of rows in the first matrix. If these two numbers are the same in the middle, then it is possible and your resulting matrix will be a 2 by 4 matrix. But what if you want to do a 2 by 3 matrix and you want to multiply this by a 2 by 4 matrix? Is that possible? The answer is correct, no, because these two numbers are not going to match and you can't do this multiplication. So this is how it works. Now let's see how it's actually done. So what we have here is these two matrices. The question is multiply if possible. So let's see if it's possible first. This is a 3 by 3 matrix. This is a 3 by 2 matrix, the number of rows by the number of columns. These two numbers are the same. Yes, possible. We are going to end up with a 3 by 2 matrix when we finalize this. Now to the tedious part. So what you do is you multiply a row by a column. So you're going to take this row here, I'm going to show you one of them broken down, this row by this column, number by number. So you're going to do 3 times 2, that's 6, 1 times 4, that's 4, negative 1 times 1, minus 1. Okay, that's going to give you the first row, first column. Second row, second column, this by this, 3 times negative 1 is negative 3. 1 times negative 3 is minus 3. Negative 1 times 2 is minus 2. So you do the same thing now with the second row. Second row, first column. 2 times 2 is 4. Negative 2 times 4 is minus 8. 4 times 1 is plus 4. Second row, second column, 2 times negative 1 is minus 2, negative 2 times negative 3 is plus 6, 4 times 2 is plus 8. And finally we're going to do the last row. So 5 times 2 is 10, 0 times 4 is 0, 1 times 1 is 1. Third row, second column, 5 times negative 1, negative 5. 0 times negative 3 plus 0, 1 times 2 plus 2. All we need to do now is do the math here. 6 plus 4, 10 minus 1 is 9. Negative 6 minus negative 8. 4 minus it, this is going to give us 0. Negative 2 plus 6 plus 8 is 12. 11 and negative 3. This is our product. Alright. Second question, example 2. Multiply if possible. Is it possible? Let's see. This is a 3 by 2 matrix. This is a 3 by 3 matrix. These two numbers don't match. Nope. Can't do it. So we can't multiply it. Don't even try. Example 3, it's a 2 by 2 matrix multiplied by a 2 by 1 matrix. These two numbers match. Yes, we can do it. So we're going to do the same thing, multiply, and the result will be a 2 by 1 matrix. So multiply row by column. So multiply 1 by negative 5, that's negative 5. Negative 3 times 6 plus negative 18. And then we'll do the second row, 4 times negative 5 minus 20. plus 3 times 6 plus 18. And it's going to give you negative 23, negative 2. And that's done. Okay. One more example. This is actually a fairly common mistake that I'm going to address right away. Just because matrices have exactly the same dimensions does not mean anything. These two matrices are not possible to multiply. This one is 2 by 3 and this one is 2 by 3. And unfortunately these two numbers don't match, so you can't multiply them. Okay. Here, however, you can. This is a 1 by 3 matrix and this is a 3 by 3 matrix. The middle numbers match. You are going to have the resulting matrix that's going to be a 1 by 3. And all you need to do is multiply that. So let's do that. So we're going to have 1 row and 3 columns. So 1 times negative 1 times 2 is negative 2. 6 times 6 is plus 36. 2 times 3 is plus 6. The same row by the second column. Negative 1 times 0 is 0. 6 times negative 1 minus 6. 2 times 5 is plus 10. And finally, negative 1 times 1 is negative 1. 6 times 2 is plus 12. 2 times negative 2 is minus 4. So, all in all, negative 2, that's going to give us 40. This is going to give us 4. And that is going to give us negative 1 plus 12 is 11. 11 minus 4 is 7. And that's the answer. One last thing that I want to address. So we have these two matrices. They're both 2 by 2. So here it's asking you to find A times B and B times A. And then what we are interested in, we want to know if we multiply them, are we going to get the same answer? So I'm going to show you, we're going to do it with the calculator. So what I'm going to do is I'm going to store each matrix here. So I can also show you how you can do this on the calculator. So I'm going to go to the edit menu. I'm going to need to change my first matrix to a 2 by 2 matrix. 1, negative 2, 6, 3. And I believe I already have matrix B stored here. 2, 4, negative 1, 1. Yes. So when we exit this, I'm going to go to matrix, select matrix A, times, go to matrix, select matrix B, and multiply that. So when I multiply A by B, this is the matrix that I have. So A times B is going to give me 6, 2, 6, 27. Okay. So what happens when I multiply B by A? I'm going to go to matrix, select B, times, I'm going to go to matrix, select A, multiply that. As you can see, we are not getting the same answer. So the important lesson from here is, our answer here is going to be 26, 8, 4, 7. A very important lesson that A times B, in this case, and as a general rule, is not going to equal to B times A. And that's providing that multiplication both ways is possible. So multiplication, matrix multiplication as a general rule is not commutative, which means unlike numbers, when you multiply two numbers, you can switch the order. When you multiply matrices, if you switch the order, you most likely are not going to get the same exact result, and it may not even be possible to do. Okay, as a matter of fact, if I go back to this problem, I don't know if you noticed or not, this was example 1, and we multiply these two matrices, and it was possible to do. I'm going to show you example 2. I don't know, you may notice that it's exactly the same two matrices here, but I switched the order, and what happened here, it wasn't even possible to multiply them. Okay? Put your questions in comments. I hope this helps.